Okay, this is U3A5. This is the final activity in Unit 3, and what we're looking at are reaction rates. They talk about 6 things that affect the rate of a reaction in this activity. And what you're going to notice is that all of these will affect how a reaction rate goes. And that's going to be very important in industry where you're trying to make money, so you want to make sure you've set things up as efficiently as you can. Nature of reactants goes to the point of, are they gases, solids, or liquids? Some things react better than others. In general, the higher the concentration of reactants, the faster the reaction. So for example, if I had 1 molar versus 11 molar hydrochloric acid, the stronger the acid, the faster it works. Surface area. If things aren't going fast enough in the lab, crush them up. That gives us more surface area. So if we grind things down into finer particles, the reaction goes faster. Most experiments go quicker if the temperature is higher and the pressure is higher. Okay? And then catalysts. A catalyst is something that will make a reaction occur that's naturally going to occur, but it'll make it occur more quickly. So a catalyst can't make something occur that won't naturally occur. So what catalysts do, if we have a reaction, so if we have energy in reactants and we want a reaction to occur, we need an activation energy. The simplest one I can come up with is we've got a log and we want to burn it. So what we have to do is we have to put energy in. So we have to light the log on fire. That's putting energy in. What a catalyst does is it lowers the activation energy, or the energy needed to make a reaction go. Just taking a look at this reaction right here, this one's exothermic. The products have less energy than the reactants. This is our activation energy. This is what the catalyst does. It lowers that activation energy so that this exothermic reaction can occur. If this was an endothermic reaction, it would be the opposite. Our reactants would have energy down there, our products would have energy up here, but we still need to put energy in to get this reaction to occur. So this would be an endothermic reaction, energy in, exothermic, energy out. All the catalyst does is lower the activation energy so that that reaction can go more smoothly. Now, the next thing they talk about in here are rate laws, and one thing they miss out on are reaction mechanisms, so they briefly mention these. I'd watch a couple videos on this if you plan to go on and study chemistry at a higher level. But let's talk about what rate law does. A rate law tells us, in general, how a reaction's going to go. So it doesn't say high pressure, low pressure, high temperature, low temperature. It just gives it a rating in general. To do a reaction mechanism, we've got to take a reaction. So we're going to take 2A plus B gives C plus D. And it rates that reaction. So here we go. We don't worry about the products in reaction mechanism. We study the reactants. So what we do is we set up a general experiment. So we'll call this experiment 1. We'll have a concentration of 1 of A, 1 of B, and let's say our rate is 10. We can measure rate in different ways. We can look at use of reactants. We can study, we can study conductivity, we can study color change, whatever it is, we can measure that rate. So I'm not going to use units here, I'm just going to show you how this works. In general, here's how a reaction works. At the very beginning of the reaction goes very quickly, so this is the use of our reactants, and then as it goes on, it slows down. If we were to study formation of products, they'd be formed very quickly at the beginning, and then that would level off. Now what we want to do is we want to change either A or B. So let's double A, and let's see what happens to the rate of the reaction. If we double A, we keep B the same, then the rate of the reaction doubles. Let's do a third experiment. see if you can guess what we would do in this third experiment. Right, we'd keep A the same, we'd double B. Hey, let's say that rate doesn't change when we double B. Let's take a look at what all of this means now. By the way, the reason I put a 2 here, I put a coefficient in, is because these coefficients don't matter in this, and I just wanted to point that out. So, when we doubled A and kept B the same, the rate doubled. That's a 1. This is what we would expect. A 1 is proportional. So if we tripled A, then we would expect the rate to triple. Now with B, when we doubled B, the rate did not change. That's a 0. No effect on rate. If we doubled B and the rate went up exponentially, that would be a 2. So all we're doing right now is we're rating our reactants. So our A is a 1, our B is a 0. Here's the formula you always set up. Rate is equal to K, concentration of A, concentration of B, to their exponents. This is a video I would watch a couple of times to make sure you get down this rate law thing. Okay? So, now what we can do is we can take any one of these lines and substitute it into the formula. Any one of these lines would give you the exact same answer in the end. And what we're solving for is K. K is the constant for the reaction 2A plus B gives C plus D. K is the constant we're solving for. So we're going to rearrange this. We're going to say K is equal to the rate of A to the 1, B to the 0. Now, like I said, we can take any one of these lines and put the data in. We'll get the same answer. Because it's a constant, we'll keep getting the same answer. Let's use the second line. Any number to the 0 is 1. Any number to the 1 is itself, it's 2. 20 divided by 2 is 10. Our rate constant is 10. Folks, this is the whole background to rate law that I've just done. You might want to watch a couple of videos on rate law, but basically you figure out your exponents for your reactants, rearrange the formula, solve for K. Now, the other thing they can do here is they can give you the K, they can give you the exponents, and they can give you the concentrations of A and B. Square brackets means concentrations. Concentrations are moles per liter, and they can ask you to solve for the rate. So they can give you the K, they can give you the concentrations A, B, and the exponent, and they can ask you to solve for the rate. So you're either going to find rate or you're going to find K.